Let's have a look at this scenario. The ice on our lake is 0.010 meters thick. The lake is circular with a radius of 480 meters. And find the mass of the ice. Well, first thing we do, we'll take all of this and turn it into a little picture. We'll draw a diagram. So we have a good understanding of what is being asked of us. So it's a circular lake. Here's a circular lake. And on this lake, there is ice. And the ice, as you know, will float on top of the lake. So I'm going to give this ice here some thickness. And underneath it is water. It's a circular lake. And the radius of this ice that's floating on top of the lake. And well, to make sure this is, just to give it some depth here, we'll put some trees surrounding the lake here. We'll be in northern Ontario. Here we go. So we have a frozen lake surrounded by a forest. And this ice has a radius of 480 meters. That'd be the radius. 480 meters. And let's write down what is given. We're given thickness. That's this portion right here, the thickness of the ice. And we have given the radius of this ice. We want to calculate the mass, find the mass. Mass is equal to, we don't know. And we're also given density of ice. We're going to consider this to be an absolute value. The density of ice. Density ice is equal to 917 kilograms per cubic meter. Now let's have a look at our equations. Based on what we are given here, the equation we want to use is this one. Density is equal to mass divided by volume. Mass is what we want to find. The density of the ice we are given. And the volume of the ice, well, we need to do some calculations. Let's write our equation here. Density is equal to mass divided by volume. And when I do volume, it's a capital V, and I put a bar across it to solidify that this is volume I am talking about. It's not velocity. And when we talk about this, right, the densities, the mass of the fluid that we're talking about, or the object that we're talking about here, in our case it's ice, is also the volume of the same item, which is ice. So this equation works when you have the same items together, ice and ice, olive oil and olive oil, but it doesn't work if you have the mass of ice and the volume of olive oil. So everything here needs to be with respect to the same fluid or the same solid. Having said that, we need to calculate the volume of the ice. And we have some information here. Volume, and this is basically a cylinder. If this were drawn like this, here's a cylinder. The volume of a cylinder is the area on the top times the height or the depth. So the volume of this ice right here would be the area on the surface times the depth or the thickness of the ice. We'll call that thickness. And volume, the area, this is a circle. We're told it's a circle because it says here that it's a circular lake. And the area of a circle is pi r squared. And we're going to multiply that times the thickness. Putting in the numbers, the volume then would be pi times the radius. We're given the radius as 480 all squared. And we're going to multiply times the thickness, 0.010 meters. Now that we have the volume, even though we haven't done the calculation, it's not necessary yet, and we have an equation, we know what density is, we can go ahead and assemble the equation. Here it is. 917 kilograms per cubic meter is equal to the mass of the ice in question, or sometimes I refer to this as mice, but it's actually mass of the ice that's in question that we're trying to find, divided by the volume, and the volume we calculated to be this. Now we need to isolate mice, or mass sub ice, I should say. Isolating this, multiply both sides by the volume. Bring the volume to the left-hand side. Multiplying the right-hand side by this denominator, the denominator will cancel out, moving it to the left, and it will look like this, the equation. Pi times 480, and I'm just going to take the units out. 80 squared times 0.010, and the units themselves would be meters squared times meter, would be meters cubed. Multiply that times 917 kilograms per cubic meter, and that is equal to the mass of the ice. And the cubic meters will cancel out, leaving us the kilogram. Now putting this in the calculator, multiplication, the answer is 6637456, and the unit left over is the kilogram, and that is the mass of all the ice which is sitting here on top of the lake. Reducing this now to significant figures, the values that were given to us, 480 meters for the radius, 0.010 meters thick. How do we know these numbers? Well, somebody must have gone on here and done some measurements in order to calculate 480 meters and giving this to us into significant figures, as well as making a measurement for the thickness and giving it to us in two significant figures, the 1 and the 0. So our final answer can't have any greater digits than 2 sig figs. So we'll reduce this to 2. So 6.6. Look at that third one. It's less than 5. And we need 1, 2, 3, 4, 5, 10 to the power of 6 kilograms, approximately equal to the mass of the ice which is floating on the water. Now let's have a look at this. The ice itself, and back to our equations. Here it says the density of fresh water is 1,000 kilograms per cubic meter. And the density of seawater, having salt in it, has a slightly greater density of 25 kilograms per cubic meter. This being a lake, say in northern Ontario, it's going to be fresh water. And therefore the density of the water down here, the water itself, density of water is 1,000 kilograms per cubic meter. So I can write here the density of water equals 1,000 kilograms per cubic meter. And the density of the ice above, there it is here, is 917 kilograms per cubic meter. When something has less density than the fluid that it is resting in, that item will float. So ice is less dense than the original water itself that it was formed from. It will float. This is only peculiar to water. Water is unique in this form. If you were to take olive oil and freeze it, so here's a bottle of olive oil, and you begin to freeze it, the crystals, the solid crystals, will start to float to the bottom because these crystals will be more dense than the olive oil itself. Take any other fluid, doesn't matter what it is, take any other fluid, and you begin to freeze it. This is all liquid. And then when you begin to freeze it, the solid will be more dense than the original fluid that it came from, more dense here. The more dense an item is, it will float than the fluid itself. Okay? And the fluid here will be less dense. But water is unique. When water freezes, the opposite happens. The density of ice becomes less than the original water. And water is unique, and as a result, ice floats. So right now we are in the winter. And if I were to go to Lake Ontario and have a look around, I would see the lake, and it would have ice floating on the top. This is unique to water. Ice will float because ice has less dense than water. Moreover than that, I can also predict what the temperature will be down here, because this density is given at a specific temperature. If we look here, this is the density of water at 4 degrees Celsius. Water is its most dense at 4 degrees Celsius. And since water has the greatest density at 4 degrees Celsius, that means that the greater density water will be down at the bottom. I'll just redraw this lake. Here's the lake with the ice on top. And when we're talking about density, we're down here. Density is 1,000 kilograms per cubic meter at 4 degrees Celsius. So I can predict that the temperature of the water down here near the bottom of the lake is going to be 4 degrees Celsius. Again, this is unique to water. And the density of ice, 917 kilograms per cubic meter.